So this talk is OpenStack and network function virtualization. We believe that's a convergence of IT and the CT infrastructure. A little bit about myself. My name is Shuo. I'm a principal architect of cloud computing in Huawei US R&D Center. Before joining Huawei, I worked for Google for 4 years in their infrastructure team. So first, I'd like to talk a little bit about the relevant industry trend, because I heard people are very interested in cloud and talking, cloud yesterday. Several talking about cloud, and I think this talk, I like to share a little bit, our view toward that. So first of all, nowadays in the Valley, people are talking about software-defined everything, almost everything. So one thing, people are talking, constantly is about software-defined networking, software-defined storage, software-defined data center, and a lot of things. Other, people are building technology around this path. But talking about a cloud, we think it's a software-defined pool of resource. Virtualization, give us the mechanism that, decouple the underneath physical resource away from the up layer software. And by that, it provides an API to control the, resources underneath. With this API, it provides abstraction, aggregation, and automation. So we believe that, and actually it's happening, what has been done for the server virtualization is being repeated in the networking and storage world. By having those virtualization, you have resource consolidation. By having the virtualization, you can provide programmatic provisioning and orchestration. Then your application can scale out. Then you have a commoditization of your hardware and some layer of software. So that's all good thing, right? All good thing for the customer. So OpenStack, I think nowadays people are very interested in cloud technology, and the OpenStack in this space is something need to discuss. I think OpenStack is, has its mission. It's basically try to mimic AWS, originally. So it's basically trying to say we want to produce ubiquitous open source cloud computing platform to meet all the needs of public and private cloud. I guess by public, they are trying to say we want to provide some service that like AWS. By private, I guess they are trying to say we want to provide some service that provide similar value like VMware. So with that mission, people are providing, IT vendors are, having a lot of common interest. The first design summit was held in Austin in October 2010. So far, there's no single dominant vendor. So people are claiming that avoid vendor lock-in. And people are talking about, in this particular community, people are talking about this could be Linux for cloud. It is API-driven infrastructure. By API-driven, I mean this provides a lot of programmability and easy maintenance. So NFV, NFV is another very active topic at least in my company. So basically, try to replace the purpose-built hardware with standard hardware for better price. Right? You invest the same amount of money, you get more return. So that's another common interest from telco service provider. It is 2 years later than what OpenStack first incept. It is born in 2012 October. It is organized by a list of top telco service provider. Also, there is no single vendor lock-in. I would think, nobody is talking about that, I would think this could be the Apache family in the networking application space. Again, it adds API to control the network functionality. I believe this is the vendor's vision that we want to use IT methodology to solve the city problem. The network functionality, normally, we are talking about layer 4 to layer 7 network applications. So having talked about this high-level industry trend, I'd like to talk about the telecom operator's perspective. This is some opinion we gathered with our customers. So what's the value of a carrier when they want to invest in NFV? I think the benefit of an NFV initiative provide the following obvious commercial value. First, it is a reduction of capex. You don't need to buy special purposely built hardware for hosting a particular network functionality. A reduction of OpEx, as I said, if you have a programmable API, you have all the software orchestrated by this framework, you can reduce the OpEx. So another thing is faster time to market, right? Because everything hopefully can build with virtualized, build with the application running on top of a virtualized infrastructure. So you write code instead of building the whole stack from hardware to the software. And another thing is agility and flexibility of delivering different network functionality. So this is NFV reference end-to-end architecture. If you look at that, there are several layers. The very bottom one is the commodity, it's hardware, right? Then a layer up is a virtualization layer. Normally this is done by open source technology. And then with this virtualized infrastructure, you have a network function components. You have the related management logic, and having that, you have OSS and BSS, to basically have the whole system view. And along with this stack, there is several mapped business understanding. You have the virtualized infrastructure at the bottom. You have virtualized the network function in the middle. And then you have the whole system orchestration. So this is why we are talking about OpenStack or any other cloud technology. We believe that's a perfect platform for implementing NFV. The reason is, if you think of Huawei's traditional business, right? We sell a box of hardware, right? That could be a chassis of a blade server, and within this chassis, you have different blade server, and each blade server hosts a particular network application, and normally those one blade hosts one particular network application. That's one-to-one mapping. But what if a particular customer say, oh, by the way, this particular blade doesn't satisfy our customer's volume demand? Then we add more server, right? And sometimes this adding more server is not easy. We add more powerful blades. So that's how this traditional box software model worked. But right now, if we have this virtualized network function around, if we can run it on a pool of resource, we define that, we basically say that that's a cloud. So we can decouple the software away from the underneath blades, underneath hardware, right? We can standardize the interface between the application and the hardware. So by having that, we have much better, agility. We have much better, scale out opportunity. So this slide basically is showing us, in the context of OpenStack, what the virtual network function will look like. All the how can I say that? Okay, so very bottom, the first dash line, below the first dash line, we have all the commodity servers, all blade servers. Then the layer up, that's virtualized virtualization software. And also to manage this virtualized resources, OpenStack played a very good, important role. Basically, it can have the system-wide view of, the whole cloud resource. And as I said, having this, orchestrated and automated cloud resources, all this virtualized function applications can run as, just cloud application as is. And by the way, to better manage all this application, we need to have some kind of DevOps tools to automate this. Or some people say we may even need to build a path layer, right, to make sure the development of your network functionality is, abstract, away from the, unnecessary, bullet code. So these are the visions. These are something we keep talking internally. This is something we keep talking with our, customer. But we also see a lot of challenge. And with challenges, we think we have a, opportunity together. First of all, there is a significant difference between what NFV really wants and what a cloud can provide. So cloud, basically, if we think of how this, at least IaaS cloud originated from, that's basically the mimic of AWS. It is a computation-centric, platform. And for the NFV world, at least for the customer, we are talking about, connectivity-centric, world. And also, for cloud, traditional workload are a bunch of small apps, like web application. And we are talking about, in the NFV world, we are talking about a bunch of big apps, right? If you have network application, load balancer, that's pretty heavy application. And with that, you really need to guarantee SLA. You really guarantee the performance. So how can you deal with this virtualized world? You do not have direct control over, and how can you provide similar physical layer SLA guarantee? That's a lot of challenge. But I think these are the problem in front of us, and we think together as an open source community we can work out great solution. This is the same diagram, but this slide is basically saying, if you really think of the traditional benefit of box model, right? Box model give you the guarantee of fabric, give you the guarantee of physical resource. But how can you, when you migrate to this, cloud or virtualized world, how can you guarantee the management, the SLA, right? That's a lot of challenge. Specifically, back to the OpenStack, we think there are lots of challenge around, running NFV on top of OpenStack. But we can just list, several. For example, the first thing we identified is the cross-DC hierarchy resource scheduling. By that, I mean, if a single Telecom application instance, right, it needs to run across multiple data center, right? Because connectivity is is need to guaranteed for your end server, end user, and also affinity scheduling. For example, high availability is one of the fundamental requirements for telecom service provider, right? Normally you guarantee 6 nines. But so with that, how can you govern the redundancy and the performance, right? Because if you think of this, if you think of what AWS is telling us, is teaching us, you are going to build your application with a mind that the underlying infrastructure can potentially fail. So I think that's a lot of opportunity in front of us. So another thing is cross-version upgrade. I think OpenStack right now doing this a little bit better. So I probably wouldn't go through all of these three. I'll just use one as give you an appetizer discussion. So for example, currently there is a concept in OpenStack called cell. Basically, cell provides a tree-like scheduling mechanism. But when we talk to our customers, that normally doesn't work. In the NFV world, you need to have some kind of mechanism to configure firewalls for intercell non-HTTP traffic. How can you deal with that, right? So that's just a quick overview. This thing, basically, lots of writing here, but one word to take away is, currently OpenStack has this concept called availability zone and host aggregates. Basically, those are, things to categorize your underneath resource. So basically, that's not sufficient for us to have the upper layer application to get scheduled. Then how can we do that? I think that's a part of task for us to work through the OpenStack community. Say, oh, this is some feature we want to. This is some scheduling capability we need to have before we can have a smooth NFV application running on top of OpenStack. So this one basically is saying, to guarantee the performance. Remember in the traditional box model, you have a list of boxes co-located together, right, using the physical wiring. So with that, the adjacent network application is chained together, nearby. And how can you achieve that in the cloud world, right? So we basically say we should be able to have a kind of container, right? This container contains a list of, a trained cloud network application, right? So that they are wiring together to each other. So that's just some very high-level discussion. I think this is probably the last technical detailed slides. So basically, I say application-centric networking platform is basically a task for NFV initiative. We want to provide the application container to provision and manage the applications. And for service providers' requirement, we need to have application level HA and data protection, right? As we all know, cloud could fail, and how can you build reliable application with the could potentially failure underneath infrastructure. And application monitoring and SLA guarantee, that's another topic. The topic is about when something happens, how can you dig out the root cause? And if something is running, how can you guarantee and make sure the SLA is met? So I spend a lot of time talking about challenge. I think challenge gives us, as engineers, as technologists, and unfacing technology opportunity, because facing challenge is the only constant in this industry, right? And if we are talking about NFV and if we're talking about cloud, I think telecom service provider is really the true people understanding NFV, the real needs, because they have first-hand operational experience. And for telecom solution vendors like Huawei, like all the other vendors, these guys have telecom networking stack understanding. They accumulate decades of engineering experience. If these two community can talk to each other, and in an open source way, right? OpenStack provide a common platform for these two two group of folks to talk to each other, because service provider doesn't like vendor lock-in. And OpenStack could provide that openness. And with that, people can say, let's forget about this underneath complexity. Let's focus our discussion to the value as on application. With that, I think I conclude my talk. I look forward to discussing with you.